Why such a video? I've got this thing installed in my door, and despite the note about the long battery life, you can expect that this note may be misleading sometimes, especially in my situation where I've got set up a triggering thing, which is the camera will check for changes in the pixels in the selected areas, which is lovely. Anyway, if if this one points out to the busy street, like in my case, the trigger is quite often, so it saves the 10-second clip every time something changes in its view, but that drains the battery quite quickly. So in my case, I wanted to replace the recommended batteries with something else. So my idea was to take out the batteries and replace them with some dummy batteries with the terminals to have the possibility to connect anything like rechargeable batteries for the doorbell. And this is what I'm showing in this video. And this is the hero of our story today. We've got a doorbell wireless, it's contacting with my Wi-Fi and then the rest of the system. So what I've got here, I purposely disconnected it from the bottom so it sticks correctly on the bottom, so don't worry, it's not like that to be, you know, dishonor for the maker. It sticks all right, but I took it and pry it off just for this purpose of this video. When we open it here, you can see the wire which provides the power to the system, to the doorbell. I took the original 2 times 1.5 volts batteries and brought this one. So we've got wire drill through the frame of the door, and it comes out here, and this box has 2 batteries inside, just standard 3.7 volts taken out from the old laptop battery, and the charging system, the charging board, which provides protection of overcharging and also provides the possibility to charge the batteries. And here they are, the heroes of our story. So the bell itself and the battery package in its own 3D printed casing. This is double-sided tape to stick it to the wall, and then there's a strip on the back which sticks to the frame door, as you saw it in the previous previous part. So yeah, you see it's falling apart. So we take it out, and what we've got here is just my custom-made little thingy. That's like a little spring here to release the batteries from its place if you want to. So what I did here is this little thing is like a rivet or something made of copper. So I placed it through and then soldered it quickly enough to not to melt the plastic around it, and holding its position to when it melts anyway, because copper conducts the heat so easily. So holding it, soldering quickly, and then bringing the positive terminal to the TP4060, one of these chips modules to load to charge the battery and protect it from over discharge. So that's this part. Now let's go to the camera. What I've done to the camera is I just made it in such a way that I can release the camera again or make it working on the standard way. So instead of soldering myself to the terminals in the camera, I printed those two. This is like a shape of a standard AA battery, 1.5 battery, with some tricks. So the tricks inside are this. We've got the same rivet, sorry, and this time has been soldered in such a way that doesn't encapsulate the rivet around. It's just like a slight bit, and it exists only on its side. It's still a very good solder, I would say. And this one, I just did this cutout for possibility to slide it in. You see, it just encapsulates the rivet and it holds it inside. It has only two terminals, because in the normal situation, when you've got true batteries inside, it's negative, positive, and that part is shorted here. So we've got negative terminal, positive terminal battery, negative terminal battery, comes back, and then negative there. So what we need to provide here is negative and positive terminals, which are provided by those two. And that's it. Fortunately enough, there is a nice passage here. You can push it here, and without damaging the enclosure, you can clip it here, and it's working again. Voila. There is a thing in the current battery system which I miss, which is the battery monitoring. At least some kind of indication of the battery discharge or charge level. Previous box doesn't have that part, so it's quite of impossible seeing the battery levels. And remember, the original Blink camera doorbell, it doesn't show a level for 3.7 volt battery. It shows that for 3 volts, which is 2 times AA, 1.5 volts battery. So when the voltage drop below the cutting point of the charge discharge protection board here, that's set up to 3 volts. So if the battery being cut out from the delivering the power, then it just goes without any notice or anything like that. So now with the new design, I've got this little thing, a simple thing. It's like 4 comparators with setup properly of the voltages. So the top LED or all of the LEDs will show up when it's above 4.1 volt. The last battery should be something around 3.1 volts to have some time to connect the USB and charge up the batteries. All right, so this is our patient number 0, number 1. 0 is already dismantled, so everything I could, I moved here. This is the new part, the power and the voltage monitoring level. Currently is 375 volts. The top diode will lit when it's 4.1 volts. What else? The rest is almost identical as the old one. We've got some charging here. It lights up on red when it's fully charged. It goes to green, to blue, and then shows the fully charged system. That's it. Now I'm ready to fix it to the place. That's a double-sided tape, or rather foam. It's quite thick, and that's it.